Dear students, today we are going to solve question number 14, 15 and 16 of exercise 2.5 relating to algebraic identities. The question number 14 says that we have to solve this question by making use of the suitable identity, and directly we have not to solve them by multiplying or finding out the cubes of each of these numbers. The question number 14 solution: minus 12 cube plus 7 cube plus 5 cube. Here, as proved in the earlier question, that if x plus y plus z is equal to 0, then x cube plus y cube plus z cube is equal to 3xyz. Here we will make use of this question as proved earlier. If x plus y plus z is equal to 0, then x cube plus y cube plus z cube is equal to 3xyz. Here in the question, x is equal to minus 12, y is equal to 7 and z is equal to 5. First of all, we will have to show whether x plus y plus z is equal to 0 or not. Now, x plus y plus z is equal to Shabash. In place of x we are having minus 12 and in place of y we are having 7. Minus 12 plus 7 plus 5. So obviously it is equal to minus 12. 7 plus 5 is 12. So obviously 12 minus 12 is 0. Hence, we can directly write x cube, that is minus 12 cube plus y cube plus 7 cube plus 5 cube is equal to 3xyz. That means 3. In place of x we are having minus 12, in place of y we are having 7, and in place of z we are having 5. So obviously it will equal to 12 3s are minus 36 into 7 5s are 35. So it will be equal to minus 36 into 35. 5 6s are 30. 5 3s are 15. So it is 18. 3 6s are 18. 3 3s are 9 plus 1 is 10. 0. 8 plus 8 is 16. 1 plus 1 is 2 and 1. So it will be equal to minus 1260. 1260. The second part you can do yourselves. Question number 15. we have to find the dimensions of the rectangle. Since you already know the area of a rectangle is always equal to length into breadth. The first part is we are having the quadratic polynomial, that is 25a square minus 35a plus 12. Here we will have to factorize this. So we will find the two factors, and one factor will be the length and the another factor will be the breadth. Here we will factorize this by splitting the middle term. Here the middle term we are having minus 35a and the coefficient of a is minus 35. The coefficient of a square is 25 and the constant term is 12. We will multiply these two numbers, 25 into 12. 12 5s are 60, 12 2s are 24 plus 6 is 30. Here we will have to split or break minus 35 so that the sum of the two numbers is minus 35, and when we multiply those numbers we get 300. Obviously it is equal to minus 20 minus 15, because minus 20 minus 15 is minus 35, and minus 20 into minus 15, that is obviously minus minus is plus, 15 zeros are 0, 15 twos are 30, that is 300. So we can write this polynomial to be equal to 25a square minus, in place of 35 minus 35a, it is to be split minus 20a minus 15a plus 12. It will be equal to 5a into 5a minus 4a, because 5a into 5a is 25a square, and 5a into, sorry, minus 4 is 20a. Here it is 5a minus 4, and here we will get minus 3, because minus 3 into 5a is minus 15a, and minus 3 into minus 4 is plus 12. Here we will get 5a minus 4 common. It is equal to 5a minus 4 into 5a minus 3. Here we have factored this into two linear polynomials, so one of them, therefore one of them will be the length. If length is, therefore if length is 5a minus 4, then breadth is 5a minus 3, and if length is equal to 5a minus 3, then breadth will be equal to 5a minus 4. Now we will solve the last question, question number 16. Here we have to find out the dimensions of a cuboid. Since we already know the volume of a cuboid is always equal to length into breadth into height, so volume is given in the form of an equation 3x square minus 12x. 3x square minus 12x. First of all, we will take 3 common here. 3 into x square minus 4. X square minus 4x. Again, we can take x common. It is 3 into x minus 4. So it has been factored into 3 parts, that is 3x x minus 4. Hence the dimensions of cuboid are 3 units, x units, and x minus 4 units.